So far, like 99.9% of the scientists aren't even aware of the problem I'm outlining to you. So, yeah, there is this, unfortunately. Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nederland, who has been the greatest living philosopher before me. This is one of at least 2 videos that I plan to make. I mean, this is the first one. The next one is going to be sometime later, which I would tentatively call Science as Faith. Like, why do you need faith to keep doing science? Because science is not based on anything other than faith. This would be my, overarching statement. And here, in this particular video, we shall consider a problem of interpolation, a problem of continuum, you might call it, or how I would have called it, metaphorically, something like stretching the blanket. Like you have a blanket and you kind of stretch it in between certain points. So let me describe you the problem in a few words, really. So imagine we have certain observations. There's always, almost by definition, by any logical reasoning, a limited amount of observations, right? So you have certain data points, like imagine there's one data point here and one data point there, right? And you, as a, for example, physicist, as a scientist, you claim, and this is sort of a leap of faith kind of claim, that there is a continuum of values in between them. So you're stretching the blanket in between those data points. This is what I call stretching the blanket. So let's consider a very simple example. So, for example, we have a piece of wire and we're trying to measure its resistance, right? So we apply a voltage of 2 volts to it. We measure a current of 1 ampere. Great. We apply a voltage of 4 volts. We measure the current of 2 amperes. Great. We apply the voltage of 6 volts. We measure the current of 3 amperes, right? So we only have 3 data points, but we're kind of stretching the blanket of, like we're inventing a continuum of values in between them. And we're building this, how would you call it, dependency of current on voltage or voltage on current, whichever you prefer. And then we infer from it Ohm's law, right? We're saying, well, if voltage is thus, the current is thus, or whatever, or vice versa, like whichever you prefer. So this is an act of faith, because you only have 3 data points. You can't be sure ever that in every little, subdivision of current/voltage in between, there would even exist a resistance in the first place. I mean, it's really a fundamental kind of statement that there always is some resistance, right? There always is even some correlation between current and voltage, which is completely not guaranteed. And I apologize for my outlook. It's very hot in here. Even though it's almost midnight, it's like 30 Celsius. So this is the problem I'm talking about, stretching the blanket. We only have limited data points, and we assume that even the value we're even talking about exists everywhere in between, all right? And perhaps outwards in both sides as well, which would be called extrapolation, not interpolation, all right? So yeah, like the thing, like the statement that there would never be any artifacts, any like that the value itself even exists there, etc., is just an act of faith. This statement, it's a leap of faith. So you just have to believe there is this continuity. And that's why, hence this is the first part of my 2 or whatever part series on science, is that science is based on faith. Like, you just can't make this statement without an act of faith. Like, there's no one and nothing to guarantee you there is this continuity, that the value you're trying to measure even exists in the first place, can be defined, like it wouldn't break your logic completely, etc., etc., etc. Like, if you've measured your voltage and your current, let's say, if you measured your current at 2 volts, 4 volts, and 6 volts, how are you sure you would measure any measurable, any meaningful current at 1.5 volts? Like, it's an act of faith to make the statement that you can. Of course, you may say, well, why wouldn't it be the case? I would ask you the reverse question. Why would it be the case? Like, who guarantees that? You know, if we had God, for example, God could have guaranteed this. Like, God doesn't play dice, you know, this famous argument. Like, God doesn't cheat on you. God doesn't want to trick you. But if you remove God, like, where's your guarantee? There is no guarantee, right? And this is a big problem for science taking in itself, right? So in reality, speaking more philosophically, we're kind of just grasping at small, isolated pieces of the world, if you wish, which would be exemplified by these separate measurements in the Ohm's law derivation, for example, and everything else that we haven't measured, and perhaps a lot of things we can't even measure in the first place, we're just sort of like, how do you call it, paint with this, you know, kind of continuous brush of whatever, of continuous color, continuous background color, and we essentially construct this continuity artificially, basically forging it, even where it can even not be present in the first place, right? So yeah, or at least we cannot be sure it's present. So yeah, it's like, you know, again, some sort of poetic metaphor, if you wish. It's like there is a very black night, like you can't see anything, but there are like isolated streetlights here, not streetlights. What's the proper word? Well, lights, candles. There are isolated candles here and there, and you can see a little bit around these candles, and you're kind of just like, again, kind of stretching the blanket of continuity in between them. Whereas there may be nothing in between them, you know, there may be a complete emptiness. Like you assume, you see a piece of a street here, a piece of a street there, under one candle, under another, and you assume the street continues, but like who guarantees that? If there is no God that have built this street, you know, and the God doesn't want to trick you that there is no, like, if you see the street here and it kind of continues over there, like you assume it's there because the builders wouldn't try to trick you, right? The builders of the street. Well, what if there is no builders of the street? Well, then you can safely assume, actually, that there is only one piece of the street here and one there, and we don't know what's in between, you know? That's kind of what I'm talking about here. And this is how we construct the laws of nature. Like, we interpolate them almost forcefully, I guess, like induction. Induction is always an act of faith, you know, and if you don't have God to guarantee your faith has some, how would you call it, insurance, I don't know, whatever, like you were in big trouble, you know. So, yeah. And it's what constructivism works with, you know, it's like we're building our reality actually almost artificially, and this is what happens in science in particular. And this is how, for example, like one of the examples, this is how our vision works, because like it has been pretty much proven at this point that you don't actually see what you see, if you know what I mean. Like your vision is always, like for example, you're looking at my face right now. It looks horrible, I agree, because I'm sweating like a pig right now, but like if you're looking in like every millisecond, your eyes are turned, for example, here, then here, then here, then here, then here, or whatever. And it's your imagination essentially that builds the picture of my face. Like you never actually see the full extent of my face, you know? Which is, by the way, you can even prove, at least in air quotes, because you know for sure that your screen, your display, is just a bunch of isolated pixels, right? So there is no continuum of my face even, but you still perceive it in this way. So in some way, like you believe, you have faith that there is my face on your screen, even though you can logically even deduce that it's not there, right? It's just some, whatever, electrons are hitting, like phosphorus, like whatever it is, right? And there is, again, a limited amount of pixels from which you mentally reconstruct the picture of me. So, and this is the same pattern that occurs, again, when we're looking at the world. So, to a large extent, I would say this belief, this desire to perceive continuity, is kind of more of a feature of the way we perceive the world than the world itself, which kind of means that the laws of nature are actually the laws of our perception of nature, if you wish, our desire to see patterns. So it's kind of like there's a really easy step upwards from here to deconstructing the laws of nature in the first place. And again, I would argue, like my next part would be devoted to this, in this series at least, which would be like 2 videos after this one, that if you have no God, like there just can't be any laws of nature in the first place, alright? So yeah. And I'm not a believer even, you see? So, I'm an ultra skeptic here. Some, like, pussy skeptics are against God, like the ultra skeptic is both against God and against the laws of nature, except the gods in the sense that I've outlined in my video, How to Believe in God in 2024. Watch it if you wish. Link in the description. So, yeah. Like, there are many other examples of how this pattern of perception works, like when we draw maps, for example, like we, like, literally brush the whole country in the same color, whereas, like, what is a country? Like, why do you paint it in the same color? Like, there's nothing continuous in a country, you know? Like, there's so many different things. Like, even if you take society, a country is basically some isolated settlements with huge emptiness in between. So, like, we stretch the blanket in between them, right? We still paint it with the same color. So, yeah, there you go. Perhaps, this is where we're kind of already delving into some, hypothesis land. The new perception of science that has emerged with action network theory around 1980s. Again, I've quoted Bruno Latour many times over here, etc. Like this network theory can bring us to something else, because again, networks, they underline there may be no continuum, like, you know, kind of like an area type of continuum, but there is like a linear type of continuum from one node of the network to the other. Well, that would be a very interesting way of looking at laws of nature, but so far I'm not aware of anyone even trying to achieve it or whatever. So yeah, so maybe not stretching the blanket, but stretching something more like a web would be a good next step forward, but I mean, somebody has to do it. Somebody has to have a motivation to do it in the first place. And so far, like 99.9% of the scientists aren't even aware of the problem I'm outlining to you. So yeah, there is this, unfortunately. And like, I'm a physicist, okay? So I'm mostly concerned with physics. So what is physics essentially? It's just a bunch of mathematical models of the world, right? And like it's plagued by the very same problem. Like again, the examples I gave you are from physics, and like think about this. Like even in a very general sense, how do we formulate laws of physics most of the time? It's in the form of differential equations. And even what do mathematicians tell us about differential functions, differentiable functions? They should be continuous. What if they aren't? You know, like then your equation makes no sense because you cannot differentiate a not continuous function. So you already assume when you introduce a differential equation, like the equations of quantum mechanics, the equations of classical mechanics, they're all differentiable. They're all differential equations. Well, maybe not all, but you know, most of them, the absolute majority, which means they have this implicit assumption, the stretching of blanket type of assumption, that they're dealing with continuous functions. And like, who guarantees that? Nobody! That's the problem I'm talking about here. You know, like, why do we assume that there is a continuous dependence of one value on another? We can't. There's nothing and no one to guarantee it. In fact, there is a very, like, well, maybe not very, but somewhat, frequent expression. People make, for example, well, I've encountered it in my area, in like quantum field theory. Specifically, people talk about bona fide type of functions, which means in Latin, in good faith. So we say, well, let's assume this is a bona fide function, which means let's assume this function we've just introduced out of the blue is continuous, differentiable, etc., etc., etc. So it behaves in good faith. And I have to underline the word faith here. Like, we only have faith it behaves in this way. We cannot prove it ever. Again, if there is a God, okay, God doesn't trick us. It's a good function. Okay. God has written the world in the language of mathematics. Therefore, this function is probably continuous and differentiable and everything's cool with it. If there's no God, like, what are we even talking about? Like, we just introduced so many assumptions here. Like, it's impossible to justify even one of them, let alone all of them. You know, it's such a leap of faith. And I'm telling you, it's a leap of faith. And it's kind of a stupid faith because you're kind of, again, if you were this sort of stupid piece of crap type of skeptic like Michael Shermer or Richard Dawkins or one of these idiots, and you like deliberately remove God from this, like you're left with nothing, literally. But let's continue. So actually there's nowhere to continue. I just want to quote again my video. I'm not even sure I talked about it there, but there was a video like specifically about numbers, like how numbers relate to the world or something like that. I'm gonna link it in the description. Like, you see, the problem is in mathematics already. Like, I already told you, mathematics is just a language we use to describe the world. Like, it has nothing to do with the world itself, and which kind of, you know, is in the same spirit that I've described to you how our vision works and how, like, this way of pattern recognition / implying inductively some continuality, some continuousness where there could even be none in the first place is just a pattern of our perception, if you wish. So what I'm talking about here is, since we invented numbers, like numbers don't actually naturally happen, if you ask me, the same goes for the number theory. Like, there is a big problem still in the set theory, which is called the problem of continuum or continuum hypothesis, which is kind of stating that there is nothing between integer numbers and real numbers. So roughly speaking, well, I'm oversimplifying obviously, but integer numbers is, you know, like 1, 2, 3, 4, 5 and like -1, -2, etc. So they're like these points, right? Isolated points. And real numbers is supposedly like this continuum of numbers. So in between any two integer numbers, you can pretty much put an infinite number of other real numbers, right? But you can't do this with integers. So there is this question, which is called continuum hypothesis. Like, is there anything in between integers and real numbers? So like isolated points and a whole continuum. And you can see how it relates to the very problem I'm describing here, right? So it's sort of a fundamental problem for science. Even as basic of a science as mathematics, even though I would even claim that it's not science in the first place, all right? So there you go. Can you make a qualitative jump from integers to reals? Can you make a qualitative jump from 3 measurements of voltage and amperage to the statement there is any sort of continuum of values in between them, you know? Yeah, it's a big question. This is what by the way, just as a kind of sort of a PS here, I still really like this take of some guy, I don't remember his name, who claims that irrational numbers don't exist in the first place, because you can't represent an irrational number like a square root of 2 unless you're an idiot like Terence Howard. Then there you go ahead. So the square root of 2, you can't represent it as a limited amount of numbers, right? You can't calculate it, strictly speaking, right? It goes infinitely, which kind of means it doesn't exist if you think about it, right? Like, if you can't calculate it, period. You can approximate it, of course, with some real number, You can probably even approximate it to any degree of precision you want, but you can never calculate it exactly, which kind of means it doesn't exist, you know, which again is also one of the other side of coin of this problem of continuum hypothesis, you know, like what is reals and how are they related to integers. Yeah, so long story short, to conclude this video, what we've talked about here is that science has a fundamental problem that very little people is a bad expression in this context. Not a lot of people recognize, let's put it mildly. And the problem is that you have to make a huge leap of faith. It's essentially an act of belief. To conclude there is some sort of continuum of values, measurable values or not measurable values, regardless, between the actual values that you actually measure, right? So let's imagine, like, we're building an Ohm's law, like again, 2 volts, 1 ampere, 4 volts, 2 amperes, 6 volts, 3 amperes, right? And you just build this nice little line in between them. You don't care if in reality it's like between like 2 and 4 volts there's like huge dip, and like maybe the resistance isn't even defined in like, or maybe it's not defined in every, like, you know, like 0.05 not defined, 0.05 not defined again. Like, how do you know? How do you know there's this continuum? It's an act of faith. I'm telling you, you're actively saying, I want it to be true. This is a bona fide function, well-behaved function. Or like, how does mathematicians say? They actually say well-behaved function, right? Let f of x be a well-behaved function. So at some level, they recognize there is this deep problem, but they will never admit it. They'll never admit that if you remove God, all of this goes into bad place. We're smart people, though. We can recognize it. We can be honest about it. And I'm telling you, I don't believe in God. And unfortunately, I don't believe in science as well. Thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.